So in the previous class, we have seen the concept of conversion of ER diagram to relational model, right? Once we drawn relational model, we can get the relation schema also, right? I hope you know the difference between relational model and relation schema, right? So we have seen a 7-step procedure which is very easy to convert ER diagram to relational model, right? In relational model, you are going to represent everything in the form of tables. We can call it as relations. Whereas in relation schema, we are going to represent the form of a schema representation, where schema representation means table name followed by set of attributes which are supported by the respective table. This is what we call it as relation schema. Okay, so these are all the things we are going to do it which phase? At the design phase. At the design phase, I mean. So what is happening actually? You are you are going to get the client will give various kind of requirements. Those requirements we are going to represent in the form of SRS document, or we can simply define it as requirements gathering. Requirements gathering. Then we are going to perform various kind of analyzation, whether the asking requirements are able to satisfy by our company or not, or whether it is feasible for our company or not. They are going to analyze. After that, they are going to move for design phase. If all are going to be satisfied. In the design phase, one kind of model they can able to draw is ER model. ER model, where everything is going to be represented in the form of pictorial representation. That is easy for the client to understand the entire database system structure. But the thing is, nowadays, if you observe any kind of databases, all databases are related to relational databases. All databases are related to relational databases. For that, there is a specific model is there, that is relational model. Relational model, right? Once you know ER model, you can able to easily convert it ER model into relational models also, right? Once you know the relational models, you can able to simply define its relation schema. Its relation schema, right? So these are all the things that is going to happen in the design phase, right? Meaning that you can try either in ER model or relational model or in the relation schema phase, right? So the reason why the relational model is very important is nowadays all the databases are using relational database management system. You can simply call it as RDBMS, right? You know the meaning of DBMS, database management system. It is a kind of a software which you to manage the storage of data as well as trying to perform various operations on the stored data, right? Relation means which we are trying to perform on the relations which are stored in the database, right? So the thing here is the most commonly used language in order to work with RDBMS software is SQL. SQL is a kind of a language which you use to communicate with RDBMS softwares, right? Structured query language, right? So the basic thing behind SQL language is relational algebra and relational calculus. These are the two heart of the components of SQL, right? So if you have to clearly understood the concepts of SQL, first you have to know the concepts of relational algebra and relational calculus, right? Meaning that if you would like to perform some kind of operations like insertion operation, or some kind of operations like selecting of data or gathering of the data from the database, you have to write SQL query, right? How you are going to write the SQL query? Based upon some mathematical logics. All those mathematical logics are represented in relational algebra. The alternative for it also relational calculus. Okay, so now in today's class we'll see the concept of relational algebra. Okay, so relational algebra is a kind of a language which you use to perform various kind of operations, which is used to perform various kind of operations on where relations, not relationships, relations. We are going to perform various kind of operations on relations. We can simply generally call it as tables, and its result also will be available in the form of relations. That is the general meaning of relational algebra, right? With the help of relational algebra, if I am going to have a table, this kind of structure, something like serial number 1 2 3, This is the relation. On this relation, I am going to perform certain kind of operations. Those operations can be something like select operation, or something like product operation, or something like this is what minus or set difference we can call, right? So like this we can able to perform various kind of operations. All those operations are going to perform the relations, and the result you are going to get is again once again a relation, right? For example, I would like to select the student serial number is 1. Student serial number is 1. What you are going to get? You are going to get once again a relation, that is serial number 1. That's it. So that is the definition of relational algebra, right? Simply we can say that relational algebra is a procedural language. It's a procedural language, whereas relational calculus is non-procedural language, or I can call it as declarative language. Declarative language, right? Procedural language means the name itself is clearly defined. We are going to define the procedure how to get the data, right? If you would like to get the data in relational algebra, we are going to simply define the procedure how to get the data. But whereas in relational calculus, we need certain requirement, but we won't say how to get the data. Simply, we are going to simply tell that what to get. That's it. Means in relational algebra, we know what to get and we know how to get also. We are going to define the procedure for how to get. Whereas in relational calculus, we are going to know only what to get, but we cannot able to define how to get the data. So if you want in depth about this, we'll see in the further classes. Okay. Now, in today's class, we'll majorly concentrate on this relational algebra concept only, right? So basically, in relational algebra, we are going to perform various kind of operations, right? So basically, this relational algebra this concept is related to what? Sets, discrete mathematics. You know, right? Sets means what? Will it allow duplicate data? No, it won't allow duplicate data. Meaning that it will have only unique data. We can call it as simply non-duplicate data. Non-duplicate data, right? Means if I am going to perform some operation on the table, whatever the result that I am getting, will it contain the duplicates? No, because relational algebra will always provide the result in the form of non-duplicates. Okay, now fine. So if you look into various kind of operations, these relational algebra operations are basically classified as basic operations and extended operations. Extended operations. Okay, so basic operations are something like select. So the symbol for it is row. Is it a row? What? Sigma? Can I call? Okay, row is something different, right? Row is something related to P, right? Okay, this is sigma. Sigma is the symbol which is used to represent the select operation. Okay, select is one kind of operation. And this is what? Pi. Pi is the symbol which is used for to represent project operation. Project operation, right? There is a clear difference between select and project. Let me tell that later part. Here we have, what is this now? Row. Row, like it's look like a kind of a P. Row means it is a kind of operation which represents rename operation. Rename operation. And X symbol. Huh? Chi symbol? No, it's not chi. It's a cross symbol. Cross product. Cross product. Minus symbol, we can call it as minus, or I can say that set difference. Okay, fine. So these are the some of the basic operations that we can able to perform on uh, relational algebra, right? So you can observe some other kind of operations. One is union. U represents union, right? And some of the extended operations like what you observe once you find union. Can I write intersection here? Right? So I will tell the reason why I am classified under extended operations. Try to understand that intersection is one kind of extended operation. Okay, and some other like plus. Where you are going to use plus? Okay. So this is what I can call it as intersection, and this is what I can call it as join. Join is one kind of operation which we are going to use, and division is also one kind of extended operation which is used in relational algebra. Right? These are the all operations that are supported by relational algebra. In addition to this, division or modular division, both are same here. Okay. In addition to this, there are certain kind of other operations are there. We can classify them as aggregate functions. Aggregate functions. We'll see that this in the next class. Okay. Fine. So here the point is here. So the advantage of select operation is, if you would like to get the data from the table, if you would like to get the data from the relation, I can use an operation called select operation. Right? For example, I want to get the student details whose ID number is 1. At that situation, I can able to use select operation. So it is going to get what details? It is going to get rows. So if I want to get the rows from the table, I can use select operation. Project means it is used to project some of the columns from the table. Right? I want to project the ID numbers of the table. Then I can use project. I want to project name of the table, names of the column from the table. Then I can use project. Right? So it is used for to get what? Columns. Get column. Right? So like if you are going to take in depth about this, right? If I am trying to get the rows as output, can I say that it is horizontal partitioning? Right? If I am trying to take a table, the table I am trying to make it horizontal partitioning. Right? Yes. Right. How we are going to basically write means, so the symbol which you want to write is sigma symbol, sigma followed by condition, what you have to do, and on what relation you want to perform these operations. This is the symbol you have to, this is the structure you have to follow if you want to perform any kind of select operation. I mean, for example, if you look into some simple example, let me take student number, name and age. Student number is 1, J, age is 53, 2, K, age is 55, 3, L, age is 19. Assume that this is my data. So you need to write, you need to get the data of the details in the form of tuples, right? For example, I want to get the data of the student number 2, right? So student number 2, as I am asking, I can call it as a complete details or not, right? As I am trying to get the complete row, what operation I have to do? I have to compulsory use select operation, right? So on which table I need to do? For example, the table name is student. So what is the table name you have to write here? Student. On the student table, what operation you need to perform? Select operation. And what is the condition you need to perform? Serial number is equal to 2. So the meaning of this one entire thing is, I would like to select the student number equal to 2 from which table? Student table. Right? This is single operation. Can I able to combine with multiple attributes? Yes. If you want, you can able to combine with multiple attributes like or, and, like that you can able to use. For example, I am trying to write simple logic. Serial number equal to 2 and age equal to 56 from student table. Age equal to 56 from student table, right? Now what are the meaning of this one? I am trying to find out all the details of the students whose serial number is 2 as well as age is 56 from the student table. Now what is the outcome you are going to get? You are going to get empty, because there are no certain rows which satisfy both conditions, serial number 2 and age 56, which is not satisfied. But if I modify the query as 55, what will happen? You are going to get one complete row. You want to get one complete row. Okay, fine. So if I am going to do like this, so if I am trying to think that this is a table, if this is the table having n rows, minimum number of rows I will get when I am going to perform select operation, What is the minimum number of rows can I get? 0 or not? So in this particular example, serial number equal to 2 and age equal to 56, you are going to get minimum number of zeros are 0. And if I am going to apply the same operation, maximum number of rows can you get? How many maximum you can get? The total number of rows you may get, right? Am I right or not? You can able to get the total number of rows. So these are the things you have to do. Right? What about the degree of this new relation? When I am going to perform the new select operation, the minimum number of rows you may get are 0, maximum number of rows you may get are n. What about the degree of the new relation? Assuming that this degree is k. What about the degree of new relation? K. Because there is no filtration in the attributes. So the degree of new relation is also k. Right? So try to think. I am going to write certain thing. Select serial number equal to 2. Serial number equal to select name equal to j from the table student. What is the meaning of this one? I am trying to find the student details whose name is j. So basically you are going to give priority, right? Inner branch is having the priority. I am trying to find out the students whose name is j, right? This particular thing is going to result what? One new relation. On this relation, can I get, can I apply one more select operation? Yes, right? So here I am trying to do what? Filtering of filtering. Filtering of filtering. Right? This is same, I can written as what? Is there another way to write? Serial number equal to 2 and name equal to j with student, right? So earlier we have seen, right? Both common, both are same, right? The same thing, can I write like name equal to j and serial number equal to 2 from the student? Are you going to get the same result or different result? Same result, am I right? Can I write the same thing as sigma name equal to j sigma serial number equal to 2 from the student table? Both are same or not? Meaning that these two are completely equivalent, right? It means what is this property? If you know the property of commutative, meaning that AB equal to BA. On dot operation it is commutative, on plus operation also it is commutative, right? So meaning that select operation is commutative. This is important. Select operation is commutative, meaning that while retrieving the data from the table, you can able to retrieve in any order. There is no problem in this. Okay, fine. So now you can check this one. Product operation. Product operation means what? I am trying to get the columns from the table, right? So the general syntax for this one is simply you can use a product operation on what table you are trying to perform. Product from the student table. So here you are trying to get columns, right? What columns you need to project? I would like to project only serial number. What is the meaning of this one? I am trying to project serial numbers from the student table, right? At this situation, how many minimum number of attributes you are going to get? Attributes is the number of attributes that you are writing here. How many number of attributes that you are writing here? That many number of attributes you are going to get. How many number of tuples you are going to get? 1, n. How many number of maximum number of tuples you are going to get? N. What about the degree of the relation? 1, right? So the same thing I will write like project of serial number comma age from the student table. What about this meaning? I am trying to filter serial number and age from the student table. Meaning that while displaying, you are not going to display name. That is the use of this one. So project operation is meant for to filter the columns. To filter the columns, right? Now try to think in this aspect. If I am going to write project of serial number, project of serial number, project of name, product of name from student table. What is the data you are going to get? Are you going to get anything? None. Why none? Because from student table I am going to get only name column. Name is a one new relation now. From that new relation, can I get serial number? No, there is no serial number relation. Then how can I get the serial number data? No. So that is none. That is none. Okay. I am trying to modify in such a way that serial number of product of serial number comma name from student. From what is the data now you are going to get? You are going to get the output as serial number. Serial number, right? Now I will try to modify that in a different way. Product of serial number comma name, product of serial number of student. Is it correct? No. This is invalid because it is searching for what? Serial number along with the name, but there is no name attribute in the respective resultant new relation. So you are going to get again none. So with this statement, can I say that project is commutative or non-commutative? Project is not commutative. Project is not commutative, meaning that while performing projection, you have to follow certain procedure. Either you are going to follow, so based on the requirement, you have to follow procedure. Without requirement, if you are going to do in different way, you are going to get the wrong results. Whereas coming to select operation, you can do it in any order, you will get the data. Right? Next one is a rename. Right? So if you would like to rename the data, you can able to rename it in any order. Right? For example, I would like to rename the table. I can rename the table. Or if I want to rename the attributes, I can able to rename the attributes. Or if I want to rename the combination table and attributes, I can able to do that with the help of rename operation. See, for example, there is a relation, student relation, which contains student number, name, and age. For example, I would like to rename the student name, student table name as something like capital S. Then what I can do now? I have to use a rename symbol, rename. What you need to rename? The student table name to what? Student S. Student S. Okay. This is the way you are going to use the renaming of student table name. Okay. For example, I want to rename the all the data of the student. Student S of x comma y comma z. What is the meaning of this one? I am trying to rename the student table to small s, where each and every attribute name is x comma y comma z. For example, I am trying to do like this: student of serial number comma y comma age. What is the meaning of this one? I am trying to rename only name, not name, attribute of the name attribute. Name attribute I am trying to rename. So like this, you can able to do any kind of rename operations. Okay. Earlier we have seen one example, right? This one. Try to observe. I will try to rewrite in another manner. First, I will do select of name equal to j from student table. And for this, temporarily, I am giving a name as T1. I am going to give name as T1. So here I can write it as like this also. Row T1, what is the meaning of one? This new relation name is T1 now. Right? Now, once I know the new relation name is T1, can I perform like select of serial number equal to 2 from T1? Yes or no? So at this kind of situations, we are going to use the rename operation. Okay, now. Right? So we're done with the rename also. Next thing, you can go with the cross product. Right? Before going with cross product, let me go with minus. Right? What is the meaning of minus? So simply I can call it as set difference. So basically, if you are going to have two relations. One is P, another one is Q, P and Q, right? So for example, 1, 2, 3, 4, 5 and 6. What is P minus Q? 1 comma 2. So the meaning is the elements which are present in P but not in Q. That is the meaning of this one, right? Which is not equal to intersection, right? The elements which are in P but not Q, I can call it as set difference or minus. Similarly, Q minus P, 5 comma 6, 5 comma 6. Okay, fine. Union, union, right? Union means what? If I am trying to perform union operation over P and Q relation, see here, P is one kind of relation, Q is one kind of relation. That is the meaning of it. P and Q. The meaning is I have to consider either P or Q. What is the meaning of this one? I am trying to combine both P number of rows as well as Q number of rows. That is the meaning of this one. If I am trying to perform intersection, P intersection Q, what is the meaning of this one? The elements which are common in both the relations will be comes under intersection operation. Intersection operation. For example, if you are going to take, let me take like try to think this example. I am trying to take two relations. One is P relation which contains first name as well as last name, and Q relation which also contain first name and last name, right? And I'm going to write certain set of values here. One is AB, CD, EF. Assume that I have written in sequential order, GH, right? And here in another relation Q, I am going to write CD, some random values, LM, NO, P and Q, not the table names, right? Now, if I am going to apply, P union Q, what you are going to get, ma? First thing, is union is applied on these two relations or not? Is union is applied? Yes, we can apply. The reason is it is union compatibility, meaning that when you are going to perform the operations like set difference or union or intersection, the basic principle it has to follow is union compatibility. Union compatibility, or I can technically call it as type compatibility. Type compatibility. Okay, so means union compatibility, how we are going to check? For example, if I am going to have a relation like P having attributes A1, A2 and so on AN, and there is another relation called Q having the attributes B1, B2 and so on Bn, when I can say that union compatible, both should have same degree. Degree of P should be equal to degree of Q. Is it minimum requirement, right? And also each and every attribute domain should also be same. Am I right? So this is character A, this is character C. So there is no problem. But here there are numbers, here there are characters. That should not be possible. So meaning that if I am going to take domain of attribute AI in P, that should be equal to domain of Q in attribute BA, where I value should be ranging from 1 to n. This is the meaning of union compatible, meaning that if I are going to take first column in the P and if I are going to take the first column in the Q, both should have take same domain. Same domain means same data type. Basically, in our terminology, right? So if it is union compatible, then only we will move further, right? As if you observe here, these two are union compatible, I can able to perform union operation, right? What is the resultant table you are going to get? Again, you are going to get first name and last name with what is the results? All results you are going to get, right? So here I think 4, here I think 4. Total 8 rows you are going to get. 8 rows you are going to get. But in 8 rows, as I said already, These are all the operations are related to relational algebra, which are related to sets. So how many rows we are going to get here? There is one duplicate you can observe, CD and CD. So total you are going to get as 7 rows. 7 rows, right? Whereas coming to SQL, this is not the case. In SQL, even duplicates are there. You are going to get 8 rows, because that is the result what you are getting. We are not thinking about the duplicates or non-duplicates. Okay, but that is what you have to differentiate, right? If you observe the P intersection Q, what is the P intersection Q? First, they should be union compatible. Yes, P intersection Q. So what is the result you are going to get? CD. Common things you have to observe, right? What is P minus Q? First name and last name. So P minus Q means the elements which are present in P which are not present in Q, right? If you observe here, except CD, remaining all are not present in Q. So I can take 3 rows, AB, EF and GH. EF and GH, right? Guys, if you observe here, if you are going to perform, so right, so as like I have asked earlier, if I am going to perform union operation, if I am going to perform intersection operation or set difference, minimum number of tuples you are going to get, how many? Maximum number of tuples, how many you are going to get? Can anybody? Can you guess? If I am going to have two relations having P and Q, this having n tuples and it having m tuples, and assume that both are union compatible. On union, minimum number of rows you are going to get. How many? Minimum how many? N. Why n? 1. Union means what? Either, right? We need to combine both tables. So it is n plus m, right? Maximum n plus 1. What about minimum? What is the meaning of this? If n and m are same data. Okay. 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 So in that situation, it is right. If you are going to think that, right, if you take like this is P and this is Q. This is Q. At this time, what will happen? You are going to get n. Minimum is n. Minimum is n, right? Okay, fine. So here, I think you'll get multiple options, right? So, like, if you are not going to think about duplicates, right? This is the case you are getting when n you are getting when P is Q is subset of P. Q is subset of P. You are going to get n. When you are going to get m tuples when P is subset of Q. Assume that both are disjoint. Q and P are disjoint, right? Try to write out the case for disjoint. When when both are disjoint, will you going to get n plus m or not? Is it correct now? Right? When both are disjoint, minimum is n plus m and maximum is also n plus m. Is it correct now? Yes. But when it is subset of one among each other, then you are going to result will be changes. But for maximum also same. You are going to get, right. Next, what about the intersection? Minimum is 0, means when there are disjoint. When they are disjoint, minimum is 0. What about maximum? N or M? N or M. That is also depend upon the way that we are representing. N or M, right? What about set difference? Minimum is 0. Maximum? Again N or M. here you are getting multiple cases, right? So if you observe here, both are disjoint. When both are disjoint, what is P minus Q? When both are disjoint, it will be P. P means N, right? Okay. When both are disjoint, it will be N. According to our relations. According to our relation, right? Okay. Is there any chance to get 0? When one is subset of another, are you getting it 0 or not? Right? So if you think like this 0, when P is subset of Q, at that time P minus Q is what? 0. 0 you are going to get, Q is subset of P also. Right? Depending upon multiple cases you are going to get. Am I right or not? Right? So this is N is correct. When both are disjoint. Both are disjoint. That is also formula for P minus Q. Not for Q minus P. If it is Q minus P again, that will be M. Right? So the reason why I am discussing it, right? In the questions you may get this kind of questions. So you have to think in such a way that it has to satisfy all these requirements. Okay. And one more thing I am getting question here. Is this is correct? If this is correct, right? That is my question. Right? NRM is not correct. It should be minimum of NRM. Right? So when you are trying to perform intersection, definitely you are going to get, if it is, see, try to think, if P is subset of Q or Q is subset of P, definitely you are going to get minimum of both. That's it, right? So it will be minimum of NRM. Okay. Right? So try to think, I will give some real time example here. I'm trying to write one table called CSC, where assume that it contains serial ID, marks, subject, and faculty ID who is teaching the subject. I have written this data in a particular table, okay, called CSC, where it contains 4 students, 1, 2, 3, 4, whose marks are 97, 9, 10, and 20, and assuming that DBMS, the and the 10, 12, 2, and 2. So what is the meaning of this table? Right here, the DA subject faculty ID is 2, who is teaching for student number 3 and 4, and DBMS teaching by 2 faculty, one is 10 and 12, for different students. Both got best marks. This is what the table name as CSC. And there is one more table called ECE. ECE, let us assume that here also serial ID, something like instead of marks I am trying to take it as result, I am trying to take it as subject, I am trying to take it as faculty number. Now assume that on these particular two relations, can I apply union, intersection, and different set difference? Yes, right. So you have to think like just union compatible. Union compatible means you have to check for only type compatible, like data type you have to check, right? But should not compare like marks and result. Marks is of type integer, result is of type also integer. Faculty number is of type integer, faculty is also of type integer. So degree of relation is 4, degree of this relation also 4. So this is union compatible. Okay. Fine. I'm trying to write something 5, 6, 7, 8. Right? This is the data. This data, right? So here there is a faculty who is, the ID number is 12, who is teaching DBMS as well as Java in EC department. Is it possible or not? Yes, according to this apprentice, it is possible. Now try to think. I would like to apply union operation. I would like to, for example, uh, I have a question. Find out the students. Whose marks are greater than 90 from CSC. What you will write? you have to take the select operation. So you should not tell the result. You have to write the query. Select operation from which table? CSC. I want to find out the students whose marks are greater than 90. So can you able to have the factor like marks greater than 90? Greater than 90, right? On this result, I am renaming this result table as something like, for example, R1. R1. Okay. Similarly, I would like to find out the students whose results are greater than 90 from EC department. From EC department. So then what you are going to write? Select result greater than 90 from EC department, and whose table name I am going to write as R1 and R2. Now my question is, find out the students, who has got more than 90 marks either in CSC or in EC. What you are going to do? R1 contains some data, R2 contains some data. If I am going to get combine all those two, is it the requirement or not? Right. So what you can do simply, R1 union R2, that I am going to write in a relation called R. This is where you are going to get the concept of unions. Okay, now. Fine. For example, I am not only need to get the details of the students who got more than 90 marks either in CSC or EC. I need to get only their faculty IDs. I need to get only their faculty. Then what you can do? See, on this particular relation R, what you are going to have? You are going to have all the data, serial ID, marks, subject and faculty ID. But I don't want all this. I want to have to find out only the faculty who taught that subject. Then what you can do? Can I do project? Very good. Project of faculty ID from the relation R. Now here we modified it. See, this is a new table. We are not thinking about these existing tables. Whatever the result that we got, we made them in the result R1. R1 is a new relation now. R2 is a new relation now. And their union is in new relation called R, where the attributes also renamed with some other name. At that situation, it is correct. Right? You should not think about the old data. That is the reason you are using the rename operation, right? So the meaning of this also rename only. Huh? Right? You can able to rename it, right? Something like serial ID, marks, subject, and faculty ID. Here also it will rename as serial ID, marks, subject, faculty ID. Now both are same, right? If it is mentioned, there is no problem, right? So, but coming to SQL, you have to compulsory specifically mention, as it is programming. It is like a theoretical concept, right? So no need to specifically mention. That is what my point here. Okay. So this is correct. Okay. Fine. But for example, I want to find out the faculty who are performed, whose students performed more than 90 marks in both branches. Then is my question is understood, right? Here, FID of R. What does the meaning of this one? I am trying to get all the faculty who involved to get more than 90 marks from both CSC as well as ECE. But I want to find the faculty whose students got more than 90 marks in both departments. Now, what is the answer for this? Only 12. How we are going to get this only 12? Then you have to apply the concept of R1 intersection R2. R1 intersection R2, right? My question is, I want to find the faculty who involved in the students who got more than 90 marks from only from the CS department. Then you have to apply R1 minus R2. Okay, na? Is it okay, everyone? Right? In the first case, I am trying to think about, I need to get all the faculty who involved to get more than 90 marks either of the from CSC or from the EC. right? In the second case, what? The faculty who involved to get more than 90 marks, they have to be common in both departments. That is what? Intersection. And third case is what? I want to get the faculty details who involved to get more than 90 marks only from CSC. Right? If that faculty is involved in ECE, I should not get that result. At that time, I will go for R1 minus R. Is it okay? Right? So I think all these are done. We'll go with cross product. Next thing is cross product. Okay. So here cross product, or technically we will call it as Cartesian product, right? It is also called as Cartesian product. If you observe, there is a table called P table, and there is a relation called Q relation. Contains n tuples, contains m tuples. In Cartesian product, how many number of rows are you going to get? N by m rows are you going to get? Right? Cartesian product is meant for what? Serial number, name, 1 2 JK, and here something employee ID, salary. Employee ID is 101, 102, salary is something, you should not confuse, right? 10 and 11, right? What is the Cartesian product of these two tables? I have to take one tuple from the first relation that need to be Cartesian product with the all the remaining two. So in your resultant table contains 1j 101 10, 1j 102 11, 2k 101 10, 2k 102 11. This is the resultant table. This is the meaning of Cartesian product. Means I am trying to take one tuple from the one relation and I am going to Cartesian product with the all the relations. So if you are going to do that, how many maximum tuples we are going to get? N by m tuples. What is the degree of the relation? Degree of the relation, np plus nq, right? Assuming that np are the number of attributes, nq are the number of attributes in q, I am going to get np plus nq, right? Okay. But in the reality, is there any meaning for this one? If I am going to have two tables, if I am trying to simply perform cross product, is there any meaning for that resultant table? No, there is no clear meaning for that, right? That's the reason we got with one more concept called joins. Right? So join is like as a cross product only, but the thing is, join, while perform the cross product, it is going to perform the join based upon certain kind of condition, right? Cross product, you are going to represent the symbol called x. Join, you are going to represent with the symbol called this one. What is the symbol? Sivudi Dola, right? So we can call it as a join, right? So the reason, so if you would like to apply join operation on both P and Q, the representation is P join operation Q. P join operation Q, right? On this, what you have to do compulsory? You have to mention certain kind of condition, because without representing condition, again it is equivalent to cross product. Right? If I are going to mention certain kind of condition, try to observe. My condition is, for example, here I modified in such a way that some other serial ID is there, 1 and 3. 1 and 3. I am trying to perform P join serial number equal to serial ID on Q. Is it a meaningful or not? I am trying to find out all the details where serial number and serial ID are matched, right? Now try to check. What will happen here? Serial number and the serial ID match. So you are going to get 1J, 101, 10 and 1. Right? Is it going to match with 1 and this 3 match? No. 2 and this 1 match? 2 and 3 match? No. You are going to get only 1 data. Right? This is what the meaning. Right? So in while applying the join condition, join operation, you are going to check for the condition, right? This condition, if you are going to apply the condition, this is what I will technically call it as theta join. Technically call it as theta join. Theta join means on the condition, you are going to take two attributes like AP is one kind of attribute, and or let me take BQ is one kind of attribute. What is the meaning? P, A is an attribute in P, B is an attribute in Q. In between these two, we are going to apply some kind of theta join, right? So the simple example, this is also comes under theta join, theta join. But the point here is, in place of theta, if you are going to use, equal to operator, then this is, I can call it as again equijoin, right? So while performing condition, writing conditions, if you are going to apply equal to operator, I can call it as equijoin, meaning that I am trying to check for equality between those two relations, right? And another kind of operations are there, like less than, greater than, not equal to. All this will comes under again theta join only. Theta join, right? So basically, join operation is meant for while performing cross product, I am going to check certain kind of condition. If that condition is an equal to operator, it is equijoin. Other than equal to operator, I can call it as theta join. Theta join. Okay, fine. Guys, try to think. Is there any chance to write? Is there any chance to write this join operation in terms of cross product? Try to observe this particular situation. Right? If you are going to add 1 3 here, what is the data you are going to get here? 1 3 1 3. Is it correct now? After adding the new data, 1J 101 10 1, 1J 102 11 3. Is it correct? Right? Now, if you want to get this data without using this equijoin or theta join, how can we get it? How can we get? Can I perform select operation on this one? I am going to perform select operation. What is the select operation? Select serial number equal to 1. Select serial number equal to 1. Then will I get only this data? No. You are going to get 3 also. But the thing is here, you have to apply one more thing. And serial ID equal to 1. Serial ID equal to 1. Then I am going to get this data. Meaning that join condition, you can able to get it from another way. What is that another way? It's a combination of select and cross product. Select and cross product. That's why join operation will becomes under what? Extended operation. Extended operation, right? Without join condition also, I can able to get it from the existing basic operations like cross product and select operation. Okay, now fine. So this is what the meaning of theta join, right? Now in this kind of join, what are the number of tuples we are going to get? Minimum how many? Maximum how many? In place of theta join, minimum number of tuples we are going to get as 0. Is it possible to get 0 or not? What about the maximum? Maximum, which is equal to again cross product, right? Tn into tr number of tuples. If I am assuming that tn number of tuples are there in P table and tr tuples are there in the Q table, I am going to get this maximum number of tuples. Okay. Any doubts, ma? Right? So basically, whatever things that we discussed so far, all will comes under one type of joins or inner joins. Inner joins. All will comes under inner joins. So inner joins means, are we going to get the lost the data or not? Yes or no? See, if I am trying to combine two tables P and Q, you need to get how many rows actually? 4 rows basically. but we are getting one data that is also meaningful data. But are we losing the remaining 3 tuples or not? Right? In inner joins, we are going to lose the meaningless data. We are going to lose the meaningless data. Right? So there is one more kind of classification is there, that is outer joins. Outer joins, where depending upon the requirement, we won't lose the data. Even the data is meaningless, if you don't want to lose the data, then we will go for the concept of outer joins. Outer joins, right? So before this outer joins, there is one more kind of join is there, which will be comes under inner joins, that is natural joinum. Natural join, right? So basically, try to observe, right? On both P and Q, I am going to apply equijoin, or can I do like serial number is less than SID, this kind of operation or not? I can apply theta join also, there is no problem, right? So natural join means, the thing here is, if I am trying to say that P is one kind of relation and Q is one kind of relation, natural join you are going to represent with a symbol called star. Naturality, without involving by ourselves, if it itself is going to perform the join operation, that is what I can call it as natural join. How it can able to perform without involving by ourselves? Just think about this. If there are any kind of common attributes, can it be is going to perform its own kind of operation or not? Right? Try to think. If I am going to have a relation with A and B, and here there is a relation Q with B and C, right? Basically, I can call this this kind of thing like P theta join B in P is equal to B and Q C. B and C, right? So instead of defining manually, you can write it as P star C. P star C na Q. P star Q. P star Q. What is the meaning of this one? It will automatically select if there are any common attributes are there, and those it is going to perform equal to operation. It is going to perform equal to operation. I hope you understood. Is it okay, ma? Right? So if there are no common attributes, how many number of numeric relations you are going to get? 0. If there are any common attributes, it is going to apply equal to operation and it is going to get the data. That is the difference between natural join and theta join. Okay. Right? But now in the resultant table, after applying the natural join, how many tuples are you going to get? Minimum is 0. What about maximum? Maximum n by q, again tn by tr, again tn by tr are the maximum. Tr. What about the degree of the new relation? Same. Degree of the new relation. Okay. In terms of equijoin, what about the degree of new relation? Degree of new relation is 4. A, B, B and C. B, B and C. Whereas in degree of natural join is 3. Why? It itself identified one column as common column, so it will remove that one. So in the degree of new relation, you are going to get A, B and C. Okay. So this is what the new natural join. So in natural join also, are we going to lose the data or not? Right? If they are not matched, data is going to be lost. So all the lost information will be comes under meaningless lost information will comes under inner joins. And if you don't want to lose that meaningless information also, then we can represent the form of outer joins. Outer joins, right? In outer join also, we have to specifically specify which table data you don't want to lose, right? Then I'll go for like this. This is what I will call it as left outer join. Left outer join. So in left outer join, it is going to perform basically the comparison operation. The comparison operation, right? Meaning that it is going to first yield all the meaningful data, and all the meaningless data is going to be removed in inner joins. In left outer join, what is going to happen? Na? All the meaningful information will be gathered. All the meaningful information will be gathered. Along with this, as I am saying that is left outer join, I am saying that don't remove left side table data. Don't remove the left side table data. And what about the right side table data? Right side table data remove and place null values in place of that. Right? So in textbooks you have to read the exact definition. Right? Here I am just defining the understandability. Right? What about in the right outer join? You are going to place meaningful data, place, maintain the right table information, and remove the left table information by placing null values. Null values. What about the another kind of operation is there? That is full outer join. Full outer join. So what are the meanings one? Try to create the meaningful relation data, maintain the left table data, right table data, as well as left table data. But while maintaining the right table data, what about the left side data? Null. Left side table data should be null, and while maintaining the left side table data, right side table data should be null. Right? So if you want to make it clear, let me take simple example. For example, I am trying to take two relations P, which contains serial number, name, age. Right? With this example, you will get clear idea. And Q is one kind of relation. Serial number, class, and fee. Right? So let me take student number 1 A with 10 age, 2 3 B C. I am taking some random numbers. Okay, fine. Student number 4 1 and 2, class number C2. Assume that C1 C3 1000 2000 and 3000. Right? These are the two tables that I am having. Okay, so basically if you are going to perform P join serial number equal to serial number on Q, what you are going to get? What are the biggest one? From P table I am trying to take serial number, and Q table I am going to get serial number, and I am trying to perform the relation. Right? What will happen? 1 is match, 2 is match. So you are going to get 1 A 10 C1 2000. Okay, 1 is also will get. Right? Similarly, 2 B 20 2 C3 3000. Guys, how can we get the now on like particular attributes? For example, only I want to get only phi. Then what you can do? On this resultant relation, you can apply product operation. Right? Combination of operations also possible. Okay, and this is the meaning. So the same thing if you want to get with the help of natural join, what you can do? P star Q, simple thing. P star Q, you are going to get the same data only. P star Q means what? Serial number. There is one common attribute is there. On both this, it is going to check. Okay, fine. So here, actually we need to get how many rows? 9 rows. But we got only 2 rows because of those 2 are meaningful according to our requirement, and 7 rows are deleted. 7 rows deleted. But I want to maintain the 9 rows as usual because I don't want to lose some data, even though it is meaningless. So what I can do? I can go for any one of the joins. Right? For example, P left outer join Q on what condition? Serial number equal to serial number. Serial number equal to serial number. Then as I am saying that is left outer join, what you have to do? You have to first maintain the equal data first. So left side table you can write directly 1A 10 and okay. right? Let me write the meaningful. 1C1 2000, right? Next 2B20 2C3 3000. This is meaningful information which you know how to write. Okay. Then what about the left side table data? So the meaning is I need to write the meaningful data and don't delete the left side data, right? What about the remaining data you are going to have? 3C30. What about the right side data? You have to place simply none. This is the result you are going to get when you are going to perform left outer join. Left outer join. What about the right outer join? So in right outer join, you are going to get these two. You are going to get these two. Along with these two, in right outer join meaning is 4 C2 1000, and this should be none. This is the meaning of right outer join. What about full outer join? All these four will comes under full outer join only. Means you have to write the left outer join values as well as right outer join values. You have to remove the common characteristics. Common characteristics ante emantemma these two. Right? This is the meaning of so where here blue color represents full outer join, right? Black represents what? Left outer join, right? Red color represents right outer joins, right? So in outer joins there is no loss of data. That is the advantage of outer joins. Whereas inner joins you are going to lose the data, right? Now the question is here, what about the minimum and what about the maximum? Right? How many minimum will be existed? How many maximum will be existed? All those things, right? So for everything we are trying to discuss. So try to take, for example, if I am going to have a table with P having n tuples and Q having m tuples. I am trying to perform cross product. Cross product. What are the minimum number of tuples you are going to get? In cross product, minimum number of tuples you are going to get n into m. Maximum n into m. What about the next join, theta join? Theta join means I am trying to apply certain kind of condition. Means 0 is possible. What about maximum? Again a cross product. Again a cross product. And what about left outer join? Left outer join, meaningful information will get, and also we are not going to lose the left side table. So left side table, how many data? N. So minimum is n, maximum is nm. In right outer join, m is the minimum, maximum is nm. In full outer join, so maximum is nm. What about minimum? So can you analyze it? So what is going to happen here? I am going to write first common data. Then I am going to fill with the left side data with null values and right side with data with null values, right? So can you take some example where we can get the resultant value? In full outer join, the possibility is like if you take what about the worst case? Assume that if there is no kind of existence, I mean if there is no common thing. If there is no common thing, what will happen? N will be existed from the left side and m will be existed on the right side, right? So meaning that n plus m is the what? For disjoint data. Am I right? For disjoint data, n plus m is the rate. Is there any other possibilities existed? Okay, if they are not disjoint, then what will happen? Assume that P is subset of Q. Is it possible? When P is subset of Q, when P is subset of Q, all P will be matched as a meaningful data. Am I right? P is matched as meaningful data, and you are going to get Q number of tuples. Is it okay? Matched data will be part of Q only plus Q invalid data. So meaning that, can I write max of n comma m? Yes or no? So that's it, right? One is P is subset of Q, or Q is subset of P, or P is disjoint of Q. Huh? What? Right? There is another case is there, right? Okay, if it is not completely subpart of this one, right? At that time, you can generalize it. Hmm? Right here with this example, you can analyze how many rows you got. You got here as 4, right? You got 4. So you need to extract certain formula here, right? When a part of the data is available in both P and Q, you have to extract the formula. Maybe you may not generalize, or you may generalize. You can just try it with. Okay. So in the next class, you can just tell if it is possible or not. Right? Sometimes certain kind of questions you may not generalize. Right? Depending on the requirement, you have to go. Right? Okay. Fine. Okay. I think we did with the intersection also. Join completed, and the final one is division. What? Multiplication. What is multiplication? What is cross product? Where will get the multiplication? Okay. So let me complete this one. Division. Right? So division means, for example, try to think. I am going to have two tables, P with attributes A1, A2, and so on, AN, and Q is a table which is having the attributes B1, B2, and so on, BM, BM, right? And which contains, for example, Tn number of tuples, Tn number of tuples, and which may contains Tn number of tuples. But thing is, if you would like to perform division operation between these two, compulsory M is subset of N. M is subset of N. When M is subset of N, then only you are going to perform, you are able to perform the division. Right? So meaning that if you are trying to perform P minus Q, what you are going to basically get, the resultant attributes are which are present in P but not in Q, right? So the attributes which you are going to get when you are going to perform division of P by Q are P minus Q attributes. The attributes which are present in P but not in Q, right? So but the exact thing I will tell you now. For example, let me take a relation called student relation. On this student relation, I am going to have three attributes. One is serial number, another one is name, another one is project ID. Right? This is the relation. You can assume it as a P. Right? And Q relation can be according to this one. If you want to perform division operation, compulsory Q relation can be, like for example, it can be CSC or whatever it may be. Relation name can be anything, but the attribute should be compulsory either a serial number. Am I right? As I can say that it is subset of this one, serial number, or it can be a name, or it can be a process ID. be process ID. Or any other combination, serial number comma name, or serial number comma PID, or name comma PID, or serial number comma name comma PID. Right? So these are the only possibilities that we can able to get if we would like to perform division operation. Division operation. Okay, fine. So let me take an example. Try to think this one. For example, the relation here, P relation existed. This relation contains some numbers. Student name. I'm trying to take a student name, and I'm trying to take it as a project number. Project number. Student name is something like, assume that S1, who is working in project P1, S1 who is working in project P2, S1 who is working in project P3, S1 who is working in project P4 also, S2 P2 and S2 P3. Means here I am having two students who are working in multiple projects. Right? And I am having a Q relation where this relation contains project number as an attribute, where this project number is like P2. Project number is like P2. Now tell me the resultant attributes according to the definition of division operation. You are going to get as P minus Q, meaning that the attributes which are present in P but not in Q you are going to get. So the resultant relation contains student name. The resultant relation contains student name. Right? Then what is the result means? Result you are going to get as, so here the exact meaning of division is, if you are going to take the tuple in the denominator, that should be common for all kind of elements. Right? P2, if you observe, take here, P2 is an element which is related to S1, and the same P2 is an element which is going to satisfy for S2. Then your result is going to be S1 and S2. S1 and 2, right? So it means that simply we can say that the P by Q in this particular scenario, I can say who are working in project P2. Is it the situation or not? Who are working in project P2? For example, you can take one more example. You can get clarity. I am going to take project number where it contains P2 and P3. Now tell me what you are going to get. Are you going to get P2 P3 is common for S1, P2 P3 is common for S2. So your resultant can be student name and result is S2 and S3. Right? Here the point is here, who are working both P2 and P3. Who are working both P2 and P3. Can I do it or not? At the same thing, can you able to solve it in normal operation? Right? Sigma project number equal to P2 and project number equal to P3 from the table P. Right? So if you are going to write the same requirement from the basic operations, I can call it as extended operation. That's the reason division will comes under extended operation. Right? So take out a simple example, one more example, you will get more clarity. For example, there are certain columns whose column names are C and D from the relation P, and there is a relation called Q There is a relation called Q. It contains the column name as C. Column name as C. Right now, can I able to perform P division with Q? Yes, I can able to perform. Right. So try to observe the scenario here. A1, B1, A2, B1, A3, B1, A4, B1, A1, B2, A3, B2, A2, B3, A3, B3, A4, B3, A1, B4, A2, B4, A3, B4. Right. This is the relation that I am going to have. Right. I would like to ask the C column and Q at Q relation is A1, A2, A3, A2, A3. Now tell me what is the result you are going to get. You have to clearly understand the situation, right? So this should be, as I said, this should be common for all kind of same set of attributes, right? If you take, if you take here, if you take here A1, A2, A3, which are related to B1, is it satisfied or not? The condition is satisfied, so in the result you are going to get as B1. B1. If you take here A1 for B2, A3 for B2, what about for A2? B3, right? The result should be same. So A2 won't comes, so B2 won't comes in the resultant relation. Real relation. Okay. Uh, if you take for B4, for B3 is there any possibility? For B3 it is not possible because A1 is not at all available. So B3 is also not possible. Take out the B4, A1, A2, A3. So B4 is the resultant. So this is the result you are going to get. That is D you are going to get. Okay, number. So this is the meaning of division operation, right? So division operation you can able to get it from the uh, basic operations also. That's why we call it as extended operation. Okay, fine. So guys, what we did so far here, for example, try to think. I did here. I did here first. I am going to generate this one. I am going to generate this one because of applying the operations of P modulus Q. P modulus Q, right? So the same P modulus Q operation I can able to get it from the basic operations. The basic operations. How we are going to do it now? By using various kind of certain set of basic operations. Like first, you are trying to do the thing. First, you are going to get D data, right? You are going to get D data. When you are going to get D data, this D data is because of performing operation P minus Q. So what you are trying to get finally? P minus Q. So P minus Q are a set of attributes. I am projecting. I am projecting. From which date you are projecting? From P. From P you are projecting. So I can generally write it as pi y of P. See, I made this like P minus Q as y. Okay, fine. I am going to rename this relation as T1. I am going to give this relation name as T1. Don't, no need of all this. Just rename as T1. Right? From this relation, pi project of P minus Q of whatever the result that you are going to have Q, that should be cross product of the resultant of the earlier relation T1, relation T1. You have to subtract it from the actual table. Subtract it from the actual table. Then you are going to get the resultant table as T2. Result table as T2, right? So then the final result will be T1 minus T2. These are the three steps that you have to perform if you would like to perform the operation of P modulus Q. P modulus Q, right? So you have to make it more understandability about this one. With the help of practice, you can able to understand it. Okay, fine. What about like, so P modulus Q, I can able to get it usually using set difference, multiplication, I mean cross product, right? With the help of these two operations, I can able to get. Okay, fine. What about like the remaining things? Can you able to get join operation? Can you able to get join operation? How we are going to get the join operation? Using sigma and cross product. Sigma and cross product you can able to get. What about left outer join? What about right outer join? What about full outer join? All these things you can able to get. These things you can able to get it easily, right? So if you observe here, like, can you able to do natural join? Natural join, can you get or not? Already explained, right? Modular division, join, natural join, or if you take intersection, intersection can you able to generate with help of basic operations? How? Can I write like P minus of P minus Q? If you would like to call P intersection Q, can I write P minus of P minus Q? Basic formula, you know. Is it okay? See, I think in gate examples also, while explaining the group, I have given this one. PQ 1, 2, 3, 4, 5, 6, 7. What is P? 1, 2, 3, 4, 5. P minus Q is what? 1, 2, 3. What is P? 1, 2, 3, 4, 5. What is this meaning? Which are in P but not in Q. So the result is what? P minus Q. What is the 4, 5? Result is 4, 5. So P intersection Q represents 4, 5 only. So I can able to alternate to write P intersection Q as P minus of P minus Q. Okay now? Or is there another thing, other way? With help of union operation, can you able to do P union Q minus of P minus Q minus Q minus P. Q minus P. This is also another way you can able to get P intersection Q. Okay, fine guys. So meaning that whatever the extended operation that I am trying to define, all those extended operations you can able to get it easily with the help of basic operations. Basic operation. One is projection, sigma, cross product, minus, union. And certain times if there are any requirement to use, we can able to use the row also, right? This all what we call it as complete set operations. Complete set operations. Why I am calling it as complete set operations? With the help of these operations only, I can able to derive any other operation. That's why we call it as complete set operations. Okay, is it clear for everyone? Right? I think everything is completed, right? We can stop here. Okay, we'll continue in the next class.